All right, y'all. So we're going to go over some of these questions here from worksheet 5 or section 5's homework, which is on Desmos. Again, what section 5 focuses on is those three different styles of solving. We either solve by factoring, by square roots, or by the quadratic formula. And you need to figure out when do we use which style, right? Now, I have these set up in a way where you can just tell what it is. At the end, make sure you answer that last question where you're determining when do you solve by factoring versus square roots versus quadratic formula. But this is solving by factoring. Your first step is to get everything on one side equal to 0. That's already done. We don't have to move anything here. Your second step is let's make sure that x squared is positive. What that means, instead, if our equation looked like this, we wouldn't want to move the 6x and negative 7 over to the right hand side. We would move the x squared to the left hand side. That's already done. Our x squared is already positive, but I want to make sure that you saw that real quick. So those first two steps are done. And then step 3 is, this is a trinomial. Let's factor it completely. So we're factoring. We look at x squared minus 6x minus 7. First off, is there a greatest common factor? Always start with this greatest common factor here. We look at it, x squared, 6x, 7, they don't have anything in common, so we can't do the greatest common factor. Then we're looking at this right here. It's a trinomial. How do we factor it? How we factor trinomials is using that area model, right? So I'm just going to go off to the side here, set up the area model. Again, how it works is the x squared is in the upper left, negative 7 in this case is in the bottom right, and we can go ahead and fill in the rest of this. To fill in those squares there, that's when we're using that idea of two numbers that multiply to that last digit, which is negative 7, and have a sum of that middle digit, which is negative 6. So you think of those two numbers, the only numbers that multiply to 7 are 1 and 7. We need to get 1 and 7 to have a sum of negative 6, so the 7 has to be negative, the 1 is positive. 1 minus 7 is negative 6. Positive 1 times negative 7 is negative 7. So that works perfectly, allowing us to fill in the rest of this box. So I'm going to put the plus 1x here, minus 7x here, and we can factor. I'm going to start going through a little bit quicker when we do this factoring by area model. We look at the columns, greatest common factor there, x squared and negative 7x is x. We look at the second column, greatest common factor there. Between 1x and 7, there isn't one, so we still factor out just the 1 in that case. Now we look at the rows, x squared and 1x, what do they have in common? That's an x, right? That's what those two have in common. The next one, negative 7x and negative 7, what do those have in common? Now, this one starts with a negative, so make sure you take the negative out. They both have a 7 in common, so we have the negative 7, giving us our two factors of x plus 1 and our second factor of x minus 7. All we did there was break down that trinomial into two terms that multiply to it, and it's still equal to 0. Now, this is where it's different from what you did on worksheet 4. Worksheet 4, you were done right here, and you would just say that's your answer. For what we're doing on worksheet 5 for solving, you go one step further. To solve this, we just set each individual factor equal to 0. So we're going to go x plus 1 equals 0, or x minus 7 equals 0. If we had a third one, you would set the third one equal to 0, right? However many factors there are, if you set them equal to 0, then we can solve each of them independently. X equals negative 1, or add 7, x equals 7, giving us our answer there for question 1. Now from here on out, since we spent so much time factoring using the area model, I'm going to go through it a little bit quicker, finding those numbers and doing our factoring, because I do want us to focus on the solving part here. Alright, so I'm going to go through and do question 3 now. I'm not going to do every single question, so you can try some of these on your own here. For question 3, again, we're solving by factoring here. First step is get everything on one side equal to 0, which means in this case, we want to keep this x squared positive. So instead of us moving 3x squared and 1 to the right hand side, let's just add 4x to both sides, which means we can't combine it with 3x squared or the 1. So we're just going to rewrite it as 3x squared plus 4x plus 1 equals, the 4x's are gone, 0. We have everything on one side equal to 0. x squared's positive. Now we move on to the next step. Again, you look at this, we're factoring it completely. Check if there's a GCF. 3, 4, and 1 have nothing in common, no greatest common factor. The only way we know how to factor something like this, a trinomial, is using our area model, or if you choose some other method, use it. But I'm going to set up the area model. Again, the 3x squared goes in the upper right hand corner, that positive 1 in the bottom left hand corner. Now, why this one's a little bit different is because when we're factoring, whenever you have that leading coefficient there, you have to take it and multiply it to the back. 3 times that positive 1 is 3, so now we're looking for two numbers that multiply to positive 3 and have a sum of positive 4. Two numbers that multiply to 3 and add to 4, that's a 3 and a 1, right? 3 times 1 is 3, 3 plus 1 is 4, letting us fill in the rest of this box. So that's a positive 3x, positive 1x from these terms here, and we can factor, right? Greatest common factor of the rows, greatest common factor of the column. So I'm going to look at column 1, 3x squared, and 1x. What do they have in common? That's just an x. 3x and positive 1, what do those have in common? Again, if they don't have anything in common, 3 and 1 have nothing in common, which is fine. All that means is we're just going to factor out a 1. Now we're looking at the rows, 3x squared and 3x. What do those have in common? They definitely have a 3, and they both have an x. 1x plus 1, what do those have in common? Again, 1 and 1, the only thing they have in common is the 1 there, so we're going to factor out the 1 as well, giving us our two factors of x plus 1, 3x plus 1 equals 0. And again, we have factored it completely. You're not done there. You need to now set each factor equal to 0. So we're going to go x plus 1 equals 0, 3x plus 1 equals 0, and we're solving. So minus 1, x equals negative 1, or minus 1 here, we get 3x equals negative 1 divided by 3, x equals negative 1 over 3. Those would be your two answers here. Okay, so for future reference, when we get to this part where we're setting each factor equal to 0, probably won't spend as much time showing you that x plus 1, you subtract 1, you get negative 1, and you get negative 1 through there. I'll probably start assuming that you can just go through those a little bit quicker. If you need help, though, let me know so I can try to help you out there. Alright, so here's number 5 for you. Again, this is another solved by factoring, and keep in mind we know several different styles of factoring. We can do the factoring trinomials, which is what we focused on Monday and Tuesday or Wednesday. We also know how to do factoring by greatest common factor or the difference of squares. We can still solve the same way there. Now again, this one is solving by factoring. The way we do that is, again, get everything on one side equal to 0, check. Make sure the x squared term is positive. That's already positive, so we're good to go. We can move on to the next step, which is factor completely. So we look at this, 9x squared and 16. Start with, is there a greatest common factor? We always start there. 9 and 16, they actually don't have anything in common, so we can't factor anything out using the greatest common factor. But if you realize that 9 and 16 are both perfect squares, right? We know the square root of 9 is 3. We know the square root of 16 is 4, meaning they're perfect squares. That means we can factor this by the difference of two squares. Difference of two squares. And this will actually go pretty quick, right? Remember how I set this up is set up our two parentheses, and I ask myself the question, what squared is going to give us 9x squared? Well, 3 squared gives us 9. X to the second power gives us x squared. What to the second power gives us this 16 here? 4 to the second power gives us that 16, giving us our two pieces that we need to set up the difference of two squares. Again, how you set it up is it looks like our trinomials. The first parentheses, 3x plus 4, again from this 3x and from this 4. The second parentheses, 3x minus 4. We've factored that left side completely. It's still equal to 0. Now, it doesn't matter what way you order those. You could put 3x minus 4, 3x plus 4, that's fine. We factored it completely, and then to finish it off, you are now setting each factor equal to 0 and solving. So you get this 3x plus 4 equals 0, 3x minus 4 equals 0, and you're going to solve those independently. So minus 4, 3x equals negative 4, divide by 3, x equals negative 4 thirds. Add 4, 3x equals 4, divide by 3, x equals 4 thirds. So we end up getting negative 4 thirds, or x equals positive 4 thirds, finishing up that problem. So if you can identify that it's a difference of two squares, it will make your life a lot quicker and easier when you get through and solve these. Make sure you're able to identify a difference of squares because it pops up a lot. Alright y'all, so here's a couple of our solving by square roots process. Again, it's pretty easy to identify when you're solving by square roots because you have one of these equations here squared, right? Just a term that's squared. Keep in mind the first thing you need to do is isolate this x minus 5 squared, which in this case I already know it is. Just keep in mind sometimes there might be like a plus 1, so you would subtract the 1, but we don't have to do that. It's already isolated. The second step here is to get rid of that squared. We square root both sides. This is why it's called solving by square roots. But when we square root something squared, we have to write it as the absolute value of x minus 5. The square root of 9 is 3. The reason is because technically the square root of 9 could also be negative 3. So we're using this idea of you have to split it up into two different equations there. Right? X minus 5 equals positive 3. X minus 5 equals negative 3. And we solve. Add 5, x equals 8. Add 5, whoops, x equals 2. Giving us our two answers of x equals 8 or x equals 2. Now, obviously this one went a little bit quicker because it was already isolated, but just remember when you do the square root step, either write it as an absolute value so you know they're split up into two equations, or you can just go straight from this into x minus 5 equals 3, x minus 5 equals negative 3. You just need to know or remember that the square root of 9 could equal both a positive 3 or a negative 3. Okay. All right, so here's the next solving by square roots problem. What you need to do here is start by isolating the square root. Right, so add 7 to both sides. X plus 2 squared equals 17 plus 7 is 24. Now we've isolated this term that has the squared, right? To get rid of that exponent of 2, this is when we do the square root of both sides, hence calling it solving by square roots, right? We take the square root there, and again, there's two different ways you can think about it. How I'm going to use it is anytime you square root something squared, you need to write what's left over as x plus 2 in an absolute value, because the square root of 24 can be positive or negative. Okay, now I'm going to bring this up here. Absolute value of x plus 2 equals the square root of 24. At this point, it's probably best to work with this square root where we need to simplify it, right? Numbers that multiply to 24 are 6 and 4, 6 are 3 and 2, and 4 is 2 and 2, right? This is that idea of you pull the pair out, so the pair comes on the outside. What you didn't use, that 3 and the 2 go back in as a 6. So simplify the square root. And now we can write our two equations, right? We go x plus 2 equals positive 2 root 6, or x plus 2 equals negative 2 root 6. We solve it, subtract 2. Again, we can't do 2 minus 2 right here and say it's 0. We can't combine those, so we're just going to go write this negative 2 that we subtracted. That's a positive 2 root 6, so we can write it like that. Or subtract 2 again. X equals, again, we subtracted 2, that's a negative 2, and in this case that's a minus 2 root 6. We can't combine them, so that's what our answers are going to look like right there. The difference there from question 7 and question 5, which we just did, was you have to remember that you can simplify square roots. So anytime you have a square root, make sure you look at it, can you simplify it? Alright, so here's the last question I'm going to go over with y'all for this worksheet. This is the last style of solving that we have. It's solving using the quadratic formula. Now, we resort to solving by the quadratic formula as our last step if we can't solve by factoring. So we started out the same way. You need to isolate everything onto one side and get it equal to 0. So we're going to subtract the 3 over. We'll end up with x squared minus 3x minus 3 equals 0. We have it all on one side. Why we do that is because really we want to be able to factor this. It saves us a whole bunch of time and effort. X squared and negative 3. We're looking for two numbers that multiply to negative 3 and sum to negative 3, which that's the problem. There's not two numbers that we can go 3 times 1 is negative 3 and 3 minus 1 is negative 3. That doesn't work. We can't factor. Since you can't factor, that's when you have to use the quadratic formula, right? So for this, we have to set up this quadratic equation over here, this x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You don't have to have it memorized, just make sure you have it somewhere. And notice how attached to it, we have that a is attached to the x squared, b is attached to the x, and c is that constant at the end. So I'm just going to start by labeling our three pieces. In this case, there's no number in front of x squared, so that's a 1. Our b is the number in front of x, so that's negative 3. And our c is that constant at the end, which again is another negative 3. So we can set it up. I'm going to set it up over here because I think we're going to need a little bit of room. X equals negative b. So negative b is negative 3 plus or minus the square root of b again is negative 3 squared minus 4 times a is 1, c is negative 3. All of that over 2a where a is 1. Again, once you find these a, b, and c terms, it's really plugging it in, and then you have to just be careful. Now, usually how I like to work with these is working with this square root here by itself first, which I usually just work above it, right? I look at negative 3 squared, right? That gives us positive 9. Oops. Negative 3 times negative 3 is positive 9, so that's a 9. Now I'm working with these three right here. Negative 4 times 1 is negative 4 times negative 3. Negative 4 times negative 3 is positive 12. So really we have a 9 plus 12 inside of that square root. 9 plus 12 is 21. So we've reduced, or we've simplified that square root, so it's the square root of 21. So we can go x equals negative negative 3. Negative and a negative gives us a positive 3 plus or minus the square root of, we just simplified all of this and ended up getting a 21 all over 2. Now before we say, oh good, we're done, you need to check the square root of 21, can we simplify that? Right, break it down, 7 times 3, we can't break those down any further, so we can't simplify it, which means this is our final answer. But if it was something that you could simplify, you need to make sure you take the pairs out and deal with those, because sometimes you have to reduce at the end. Now, quadratic equation and formula, that's kind of the last thing you want to resort to, because factoring is a little bit more efficient. You don't have to worry about little mistakes that can happen over here with this square root bit. But quadratic equation does work every single time, so you can always fall back and use that. I'm going to let y'all try that next one on your own. If you have any issues with this, feel free to send me an email, and I'd be more than happy to help y'all out.